the very first thing you look for is the greatest common factor. So let's look for one of those. Let's see. X. Yeah. Oh, okay. There we go. X for the first three terms, but not the last one. So not an X, and not a numerical greatest common factor either. So the biggest thing that would divide out of 3 and 5 is 1. So nothing to worry about there. We are now in the realm of the fifth thing on the list. So it was GCFs, and then it was quadratic trinomials, and then it was the difference of squares, and then we had the sum of cubes or difference of cubes. And even though I do see a cube, it's not the sum of two perfect cubes. What I do have instead is factoring by grouping. So this is the first one you've seen of this type, and what we are going to do is factor out a GCF, but only from a couple terms at a time. So let's split this problem up. I think that's going to be the best thing to do, and we're just going to kind of draw a line there, and you don't have to draw that, but that's going to just show me that I'm dealing with first two terms and then second two terms, and then we'll put everything together and go from there. So the very first thing I need to do is try to find a GCF from the first two terms, which I do have, and it would be x squared. I can divide an x squared out of both of those, and I'll have 3x plus 5. So far, so good. And now I'm going to come over here and I'm going to try to divide a GCF out of these two terms. And again, this line right here is nothing mathematical. It's just saying, let's talk about these, now let's talk about these. So as I look at this, I realize, oh, okay, something divides out of 27 and 45. 3 does, 9 does. So let's factor a 9 out. And I said this in a previous video, that one of the things that I recommend you do is if you're ever having to divide out a GCF and your first term, and I know it's the third term overall, but with what we're talking about, it's the first term. If the first term is negative, it helps to divide that out. So let's divide out a negative. And then that means I'm going to divide out a negative 9 from both of these. Again, this one doesn't have an X, so there is no GCF there. And so negative 27 divided by negative 9 is positive 3, and then X, and then 45 divided by 9 is 5. That is also positive. So let's erase that right there. And what we're going to do now is look at what we have and see what we can do from there. The way I was taught this was to rewrite it, which I'm going to show you what the rewrite looks like, but then I'm going to show you why it looks the way it looks, because it took me a second when I was first shown this to realize, oh, okay, and that's why it works. And it was probably explained to me that way, but I was so busy trying to figure out what went where that I didn't quite piece it together. Okay, that's it. There's your next step. Now you can stare at it and figure out where everything came from. There's your x squared minus 9, and there's your 3x plus 5, and it happened twice. But what really happened was this. We actually factored out another greatest common factor, and it may not look the way we're used to it looking, but of this expression within the larger expression, I almost called this a term, but I don't know. Let's not go there. But this expression and this expression both have a 3x plus 5 that can be factored out, and we did. And I factored it and pulled it on the right side, not on the left, which is the opposite of what I normally do, but it doesn't matter. 3x plus 5 factors out, and that leaves me with x squared minus 9. Now, I'd love to stop here, but at this point, we always go back to that list. Now, there won't be a GCF because there was not a GCF from the beginning, not of all four terms. But we do have difference of two squares. So x squared and 9 is 3 squared. So let's factor again, x plus 3, x minus 3, and then don't forget this guy. He's still hanging around, 3x plus 5. So there's your first problem that you factored by grouping. Normally, if you see 4 terms, that's my first go-to thing. They're not always 4 terms. Sometimes it could be 6. It could be all kinds of crazy stuff. But 4 terms generally for me means factoring by grouping. They don't always work. And here's how they wouldn't work. If you have a GCF here, you have a GCF here, and you don't end up with the same binomial or whatever you're factoring out, then it's not going to be factoring by grouping. Okay, let's see what treasures await us. Oh, look, there's another one. Let's keep moving. I see 4 terms, so factoring by grouping might be my first best guess, but GCF first. Like, that really is my first best guess. I see all the first 3 terms have an x, last one does not. I can't divide the same number out of everything other than a 1, so let's not do a GCF, but we will do factoring by grouping, which does involve GCFs of the first 2 terms, let's change colors here, and of the last 2 terms. So there's your line of demarcation. First 2 terms, let's see, I can factor out x cubed, And that leaves me with x squared minus 25. Now, automatically, if you're looking ahead, you're realizing x squared minus 25, that's the difference of 2 squares. And there's your 5 squared right there, right? You noticed it too, I hope. Okay, over here, what divides out of both of those? Well, nothing really, but something. I can divide a 1 out, but again, because there's a negative here, let's divide a negative 1 out, and I'll have x squared minus 25. Okay, I'm going to leave that line this time. But as I move forward, what I'm going to do is factor out the x squared minus 25 because it's in both sets of expressions. So x squared minus 25, and then I have x cubed minus 1. And now we're left with something that factors a lot. Now, the obvious one is this guy. I've already mentioned that. That's going to be x plus 5 and x minus 5. We'll talk about him last, though, even though I've already said what that part becomes. This part, however, is the difference of cubes. So on our list where we had the sum of cubes, the difference of cubes, this is obviously x cubed. This is 1 cubed. 1 cubed is 1. So let's use the formula. I'm going to switch colors here. Let's go green on this one. This is the difference. So I'm dealing with a cubed minus b cubed. And that means I have a squared, ab, and b squared. And let's deal with our signs. Same sign as the original. Opposite, and then always positive. So when I'm talking about x cubed minus 1, then I'm going to have, let's see, x cubed minus 1 cubed. And so what I'm going to write here is really going to end up going right here. If you don't want to write it on the side, that's fine. But I'm going to put it here, end up putting it here, because that's going to be this binomial factored. It looks like it's not getting any simpler, but sometimes it's going to come in handy to do that. So we're going to have x minus 1. And then all my a's are x's, all my b's are 1s, so x squared, 1x, and that is positive, 1x, and then 1 squared, which is 1. So this that I wrote right here in green, that's the sound it makes, is going to go right here in the place of x cubed minus 1. So here goes, x minus 1, x squared plus 1x plus 1 squared. Now we can factor that one, and we'll have x plus 5. And x minus 5. Ah, there we go. That was fun. All right, there are more treasures that await us. Let's keep scrolling up and see. Oh, look at that one. My goodness, got the alphabet up in this thing. We have x to the 5th, a squared, x cubed. Okay, is there a GCF for all 4 terms? No, there's not. Can I factor a GCF out of the first 2 terms? I can, and I'm going to. And that would be x cubed. And that's going to be x squared minus a squared. Okay, this one's going to become very abstract. You're going to like it. Here goes. Factor out a GCF from these 2 terms, and there is a GCF, and it's a cubed. So a cubed, and then x squared minus a squared on that one as well. So I would like to think that you notice that x squared minus a squared there, obviously the same. So we'll put x squared minus a squared. That minus ran into my a. There we go. It looks like minus a negative. Now, it still does, but whatever. We have x cubed plus a cubed. And now we have a big mess. What are we going to do? We're going to clean it up. It's going to take a couple steps, actually. And you might say, someone done stole all my numbers out of my math. Math is not always about numbers. It's about ideas, and got some ideas going on here. I want to fix, not mathematically wrong, but this minus sign is really bothering me. Let's just subtract that whole thing. There we go. Better. All right. Let's talk about x cubed plus a cubed. And I'd love to write the formula again, but I'm going to stop writing the formula because we probably have the hang of it to some extent now, that I could look at each individual component and say, well, that's A and that's B. Now, I know I just pointed at an X and called it A and pointed at an A and called it B, but if I'm going to follow the structure of that formula, then I would basically say, that's the first part, that's the second part. First part, second part. First part, squared, and then multiply them together, X times A, that's AX, and then A squared, and here are my signs, sign, same, opposite, always positive. So if you wanted to write the formula out and correspond the parts, you could. It runs into a little bit of confusion because you have A in both of them, and the A is X and then B is A, and it's kind of crazy. So sometimes I just abandon the formula and go with the general structure. Okay, this is going to be X plus A and X minus A because this is a perfect square. X squared is a perfect square, A squared is a perfect square. And you could stop here if you wanted to be a little bit slack, but I noticed something, and I hope you notice it too. We have a binomial here that's also here. So why not do what we were supposed to do in the first place with exponents? And it doesn't matter what order you write all this in. But I'm going to put this one and this one together and have one exponent.